So I'm going to talk a little bit about our project Valhalla to deliver what we did in Oracle in that area. I'm not going to answer for that question, does Java need inline types? I am just showing what we have for you, and we will decide is it required or something else. So first of all, sorry for that, I have to show that slide, but I really like that kind of slide from my company. It means that I can tell you total crap, and company will be fine with that. I am protected. Okay, who am I? I am working at Oracle. I am working on Java performance. My goal is making Java faster. That is why here I will not talk a lot about functionality of inline types. I will talk what I see about performance, what we get, how it works. So, first of all, I'd like to show one simple demo for you. It's execution of two programs which pointing Mandelbrot said, zooming each frame, counted on each steps. On left side, the classic Java vault as you could write right now. The other program, when there is a caption in line, that's fine. It's a difference, it's other program, other JVM. The difference with the first program is only 7 characters. It's 6 characters for keyword in line and 1 space. That's all. You could see frame per second which we get in here and how it works. Okay, it was fun. Our Mandelbrot set is finished, and go on. What is Valhalla? Valhalla is a large project which started several years ago. It doesn't have a single goal. We have several sub-projects. But the key idea is to provide new types. We call it inline types. Initially, on the design, if you read our mailing list, our discussion, it called value types. But later, people started looking into Java language specification, virtual machine specification, and found that in Java language specification, word value, you can find it 800 times. In Java virtual machine specification, you can find it 1,000 times already. If you add more values, it will be some kind of mess. We decided to rename it. Just typical keyboard. We almost did inline types. We have a very good prototype, several set of prototypes, and that part of work became more clear for us. The other large projects which we will have in Valhalla, it will be specialized generics. We didn't started implementation yet. It's only on a prototype, on language discussion level. Of course, we have to provide library migration for all that new features which we have, and other sub-projects for Valhalla, like nestmates, which already done, and in Java, starting GTK 11. Okay, the key problem, just shortly describe what inline type is. Our goal is provide to dense memory location, and we found that the one thing which create problems for us to make a better location of data is identity, object identity. It's like it could be considered as address or something like that, memory location. But in general, it's an identity. Identity provides different effects. It's required location in heap. It's not required locking in general in other languages, but in Java, identity coupled with locking and monitors and all other things. So we decided to make a types without identity. Why? The general question, why JVM, it's smart machine, can't understand that we don't need identity, eliminate it, allocate object on stack, on whatever, do scalar replacement for it. In reality, JVM can do it. There is escape analysis, there is other things which provide better performance in that case. But I've just in case, I entered to ACM library and tried to make a search for escape analysis article. I got approximately 8,000 articles about that. Try to synchronization elimination, also again approximately 8,000 articles. Different kind of such keywords like stack allocation. Again, 8,000 articles. Probably it's the same articles because of logic and analysis is similar here. But it means that we have 300 articles per year if took into account 25 years of Java existence. It would be, first of all, it would be difficult to implement everything that people invent and write in articles. But the other thing, so high rate of articles, almost every day new article, it means that there is a demand that previous algorithm is not enough. And we have problems with that, it's too difficult to implement proper, effective, automatic solution. And we decided to put that task for you, for Java developers. You tell us where identity is not required, and we will optimize it. So it requires new types in Java. So what is inline class? First of all, it's a class. Absolutely as a class, just with simple new keyword. It has no identity. It's immutable. It's essential requirement. You can't assign null value into variables of that type, and it has no synchronization at all, of course. Like this is example of code. We assume that everything is final, all our fields is final, it's class immutable. Also, inline types has no deep class hierarchy. Every inline class extends objects, and it's final. You can't create an object hierarchy here. The only nice thing which we get here is that inline class may implement any interfaces which you wish. Okay, and other changes of semantics. There are such operations like equals or reference comparison for Java. We had a very long discussion what we could do for Java here, for inline types. Should we do false through to equals method? Should we forbid that operation? Should we make it always false? We tried that option, but it's weird. And right now we chose it's so-called substitutability check. It's like recursive comparison of two values just by field, and if it's also aggregated in line, it will be going down and down. And if you write inline class, it doesn't mean that we magically will allocate it on stack. It just means that class has no identity. Virtual machine will decide it where the data for that class will reside. So in general, if you're a third-party implementer of Java virtual machine, just to make compatible with Valhalla project, you may do nothing. You may just accept inline keyword and inline flags inside class file structure, and it will work. Nobody prevents you to allocate it on stack or on heap and doing everything what you do. But again, our key features is to embed inline types into containers, upper containers like other class or arrays. It's our key goals. And for locals, put it on a stack or completely eliminate it. And there is other two functional features which I want to emphasize here. It's like, first of all, inline types extend objects. It means that inline value could be assigned to object variable, and also inline arrays are covariant with objects or interface array. Even if it's flattened array in the node reference, you can assign that array into objects. And also, every inline type has a boxing companion, etc., etc. Right now, we had a syntaxes like type name and question mark. It's ugly syntaxes. We don't like it. We already have a direction how it will be changed. But anyway, it's a way to force inline type to be allocated on heap with only a large difference. So it can be called boxing. People used to the fact that if you box primitive value, you will get own features of identity there, like normal reference comparison, synchronization, etc. For inline types, even if you put it on stack and boxed it, you won't get identity. You still won't be able to do synchronization on that class, and the same as for reference equality. So let's talk a little. I finished with a function description. It's very short and very weak, but it requires the whole presentation to describe all features of inline types, but I want to talk about performance. For a long time, the key slogan of Project Valhalla, it was called like class work like an int. Let's check it. Let's check that inline types works at an int. So here is our a piece of code from our demo which I showed you. It's a counting Mandelbrot set for images, if you get here or not. We made complex numbers in line type, and what we get, it's comparison. It's average time, nanosecond, to make the whole computations for reference class, for primitive, and for inline class. So I see that here performance of inline class is the same as primitives. Adds its heap allocations, one operation. Another interesting fact for dealing with that graphical demo, Mandelbrot set, so it required much less heap allocation and a lot of performance benefits from a hardware point of view, and really it has much better scalability. I took my program and ran it with different amount of threads on a large server machine. And red line is a typical reference implementation of complex class, and green line is inline class. And that started almost similar. It's 30 operations per second for reference implementation and 50 operations per second for inline implementation. As you see, it's one thread, a little bit faster. But when I execute 64 threads on 64 core machine, I got 16 times boost here. Okay, let's consider other situation. I like that function. I use it for checking function invocation. How our inline types are passed through method parameters and arguments. Here, value checked for two versions, reference class and inline class. It's an argument and results. And also there is a handwritten primitive version. It works exactly as a primitive, as we have to check. Array access. What we have on one side, we have our good old reference array when array contains reference for a class, and so-called flattened array when don't have references and all fields of our inline class, they are located in the same memory. Let's check cost of random access. Blue and green, it's a primitive. It's a cost for random access to array. Rand1 is a reference. Again, we got completely joining between primitive and inline class from performance point of view. It's a random access, or maybe in case of sequential access, we'll get different results because of hardware significantly help here. Yes, results are different, but are the same. Primitive inline types have the same performance. It was short run. I'm sorry for that. I'm a little bit afraid that I will be out of time. So the first section is passed. I believe that I proved that inline types works as primitives, like an int, as it should be done. But the other section is different. Probably in my history, Valhalla project is the first project, first new feature in Java, when we not just added new feature and all other legacy code without that feature remains untouched. It was for many, many, many years, for probably the whole evolution of Java. Unfortunately, here for Valhalla and inline types, we can't do it. It's impossible. There is some impact on legacy code. And in that section, I want to tell you about that result, just to know which negative effects we got. Okay, so the key question is the following. If inline type is inlined into array, into upper class, aggregate class, into stack, method parameters, whatever, it doesn't matter. We already know that it works like an integer, like primitive types. But in some situation, we have to allocate our inline class on a heap. It could be intentionally by using type name question mark notation. It could be caused just by assigning value type into object. It's assignable to object or interface. In that case, we have to create a reference to put object into heap and leave it here. Or JVM just decided to not allocate object on a stack whatever. For example, just for comparison, the very aggressive optimization of inline types are done by JIT compiler, by hotspot JIT compiler. Interpreter of hotspot don't care about inline types and allocate everything on a heap, and it works, functionally it works. But what it means that if we have a reference, we don't know if it's inline type or not. Because of if it's inline type, semantic of some basic operation is changed. And the first operation which we have issue is our reference comparison operation equals. From one side, that is how we do it right now, and from the other side, what we have to do in case of Valhalla project. And the key question here is the cost to check if the class is inline or it's good old Java class. The first implementation, we just put that information into class descriptor, and we are going to our object. We have two internal words like mark word and class pair, and go into class descriptor to check it. It's not a good idea. It required two dereferences, and probably it required also we will get two cache misses in that case. What if to put that information about inline class into mark word? Long fight. If you look into hotspot sources, it's very tight place. Mark word, it's fitted with a bit, all other information. We are unable to find one single free bit in that mark word, but we found a pattern, which means permanently logged. Inline types can be logged, so that pattern could be used for us. And we implemented it, and right now we are doing only with one check and one dereference going to mark word. Okay, that is a code which I wrote, and check which assembly we got after compilation. That the code for the good old Java, like you will got right now. Just compare two references and doing one action on another action. That is Valhalla. A little bit more complicated, and even it's not the whole code. Because of on the right bottom corner, you could see invoke dynamic. Invoke dynamic, which should invoke substitutability check for inline types. And also there is a bunch of code there. And there is a difference. If you don't have inline types in your program, you never will enter in the green value world where our inline types processed. But even for reference classes, performance became complicated. We just compare references. The other comparison is checking for null. The second comparison is 4 or 5. It's our magic pattern that it is inline class or not. And how it costs. Other issue which we found that if your loop has invoked dynamic invocation, that loop won't be unrolled by hotspot. It's just, how to say it, we don't need it before. It's not implemented. We will implement it, but right now it's real status. And that is why on that comparison I have three different lines. One is for ACP reference, not inline types comparison, but all typical old reference comparison in case of Valhalla implementation. In case of baseline, like before Valhalla, two versions unrolled and not unrolled because of a different cost and to show it for us. In worst cases, the operation became more than 2 times slower. I mean reference comparison. In best cases, it became not so bad. Okay, other operation which we prohibited for inline types, it's synchronization. It's a throw-in exception if you're trying to do synchronization on inline types. But here everything is fine. All our benchmarks showing less than 1% difference, and we don't care about that anymore. Arrays. So if we have object array in runtime, we may have just reference array, but we may have not reference array of inline class, which is flattened. And it also causes additional runtime checks. And the other problem, we have to know that our array is flattened array. And we can't put that information inside class descriptor. because of array of the same inline class could be flattened or maybe not flattened, like represented as array of references. Otherwise, we have to make two different class descriptors and mess with having that it's the same class descriptor but different, or whatever. And we don't have a place inside mark word. We decided to do the following stuff. We need only 2 bits to preserve that information, and we did a little bit spoiling of class pointer, which resides in the header of every object. Really, it's fine to do it because of it's impossible to write a program when you will have so huge amount of classes, different classes, and class descriptors that that bit will be required. It will be not enough memory for that. What it means that for every access for class descriptor, if it's array, we have to clear that bits. They may be set up. It causes some little bit performance regression. But in reality, we checked and hotspot perfectly eliminated. But anyway, loading value from array. Just compare which action should be done in one case right now and what we'll get in Valhalla world. And the same situation, but different for a store operation. We also may have storing something inside flattened array, and it should be checked. And I won't show any charts. The situation for array access quite different. There are benchmarks which has show very huge regression up to minus 10%. And in reality, the source of all regression which we got here is not a like general inefficiency, the idea of inline types. It's just because of hotspot doesn't have some particular specific optimization which may help in that case. We simply didn't need it before, and we will do that optimization and we will check it. And the third, the last example is not related to any kind of functional semantics. What I have 2 integer arrays, very short arrays, just 1,000 elements. They are almost equal on the last element, different. I'm checking the performance of array equals operations. And that is why I'm putting difference on the last element. And here is the performance difference. Right now, Java is doing it for 600 nanosecond, and Valhalla is doing for 900 nanosecond. Could you guess what's the problem? It's integer. It's array of integers. It's not array of objects. It's array and integer. Inline type has a very flat hierarchy. We know that if it's statically type is integer, no inline types could be there. We could drop it. The problem is here. The size for generated code for method array is equals 300 bytes. Right now it became more than 5 times larger in case of Valhalla. It's just due to invoke dynamic stuff which we required to put into that methods. And our inline, the heuristics failed because of boundary just 1,000 elements. We know that issue, we found it. We are not going to tune it right now, but obviously before giving it to the public, it will be somehow tuned. Either we change boundaries or we'll do something particular specific for our inline types. But in general, the picture is not so bad I've shown you. We checked all our benchmark database. It's all database. It's no inline class code. It's just checking for regressions. No huge regression on a big benchmarks which we have. 2% on large benchmark. It's very difficult to analyze. So we started from micro benchmarks. And if dealing with micro benchmark, we will fix big benchmark, it will be fine. So when we finish with our micros, we'll go to big benchmarks. So right now I consider that the whole picture is very, very promising for performance, and I have a request for you. Right now, value types achieved pretty well situation. So the next Valhalla release, we are going to make it as a public preview feature for OpenJDK. I can't say will it be 14 or 15 right now, but it will be 14 or 15. when inline types became a feature preview in Java. In that case, you may try it. You don't need to write inline types, but you can try it for your application, for your code. And it's obvious that Oracle has much less amount of code than you. If you check it earlier, if you find some issues, performance regression, something else for good old reference legacy code, just please report it. Try it. I hope it won't take a lot of time. And let's finish talking about negative effects of Valhalla. Let's check what it could bring us for us. I have shown that the performance of inline types works like a primitives. It's comparable with primitives. But what else? Just a little bit set of examples when we can get another differences. I just even don't want to talk it that inline types is very useful for any kind of arithmetic code. We playing with complex numbers. We did the Mandelbrot set demo. We played with just simple complex matrix multiplication and got very nice result. I played with some ray trace algorithms and just adding that keyword inline got speed up from 50-second rendering one scene till 30-second, just when I did nothing. But let's consider other examples. First of all, I did a very artificial example about Java util optional. Just let me check. Who don't know what Java util optional is? Who is still working on Java 5? It's not funny. It's not funny. There are such people who has a production Java 5 still in our time. So.
It's not broken. Why fix it?
Yeah, exactly. So Java util optional is our litmus test for Java library migration. It declared that it will be a value type in the future, and it will be definitely a value type when it will be ready. It's a tricky question, will Java long integer, Java long double will be value types or not? Because of if your application do synchronization on Java long integer and will make it inline type, you will fail. And there are such people. It's the only question how much money they'll pay Oracle to preserve semantic of integers. If they'll pay enough money to Oracle, integer won't be a value type. Okay, so I tried to do something a little bit big about optional, just some benchmark to check how it helps us. Another situation, like very large discussion about bad design of hash map class. When get method may return nulls for two cases, when there are no such mapping inside our map or there is a mapping to null. Bad idea, bad design, but when hash map interface were created, there are no such class as optional. Let's make it. Let's make it as returning optional. I could do everything and measure what we get in case of such processing of optional class. And here's comparison current classical reference optional and future inline optional results. And it's average number for 1 million get operation from a hash map which has 1 million pairs. I think it's probably nice results. Another example. That task I solved in my life many times. It's like when I have several keys and I have to map several keys into one value. And I know only two ways to do it. Either I'm writing a new class composite key, name it somehow, or I'm doing map of map of map of map. I'm kindly ask you, if you know the third solution, please tell me. I'm just curious. I'm looking for that. And let's check a performance. I did simple map of two integers into one integer, 1 million get from 1 million map, and I did reference composite key, map of maps, and inline composite key. What is better? I prefer composite key from a code reading perspective. It's much clearer to understand that chain of maps, but chain of maps right now works a little bit faster, but inline should eliminate that difference. Another situation which we are working on also obvious. Hash map has entries, and entries is chained inside buckets. But what if the first entry inside chain we will flatten into our array and make it inline class? We don't care about other chain which is possible, but it's question to your hash function, not anymore. But for us, which performance results here? Results a little bit controversial. There are some interesting effects correlating with hardware, but in general, it gives performance, not a huge, but performance improvements is possible. And in that case, you even should know anything about inline class. It's an internal goal for GDK to deal with that. Another example, iteration. Just simple iteration of a hash map benchmark. And if you write that benchmark, you may find that in different circumstances, in different other environment, not in that particular benchmark, but in real programs, performance of such iterations through the whole map may require different amount of times and very, very significantly differ. Does anyone could guess what's the difference? Why it happens? Okay, here's the solution. The problem with iterator. So when it's colorized and escape analysis eliminate our iterator, we get much, much better performance. But please don't mess it with the heap allocation. That difference at 20 milliseconds, it's not a cost of heap allocation of our iterator. Because we are doing a loop, 1 million iterations, and we allocate our iterator only once. It obviously can't cost for us 20 milliseconds. What cost for us that 20 milliseconds? The problem is inside hash map and inside iterator. Problem really here. Iterator has a state, and that state has a reference fields. And that state should be updated on every move, on every step when you're going through your iterator. And if you update a reference, you have to invoke garbage collector write barriers. And that 20 milliseconds for us, it's the cost of G1, GC write barriers. It's okay, if I will run it under ZGC, when there are no write barriers, I won't have such effect, but I won't have other effect because of ZGC has other barriers. Okay, what could be done? How we can't make an iterator as an inline type. It's not immutable. To make something as inline type, you should make it immutable. What about such interface? We call it cursor. There is no way to update that cursor. It's immutable. We only just get a cursor to the next element to create it and change it for such kind of benchmark using inline cursor. And here is performance results. It's the same with colorization, no GC barriers. We are happy. The only best way is that we don't rely on escape analysis and we always get nice results. And probably my last example for that talk. In general, every program doing the following. It just moves one data from one place to another with some permutation in the process, but what we are doing is moving data from that place to that place to that place, etc. And looks like common sense that cost of moving inline types will be higher. They are larger. We don't have only simple 4 or 8 bytes reference for old heap allocated object when we're just moving our reference and don't touch our objects. In case of moving inline types, you have to move the whole object if it's from one array to another. And I choose that as sorting algorithms will be a very nice example to measure data moving performance. I did 3 implementations. One, I took the basic default team sort reference from GDK. The other, I identically re-implemented it for inline types, exactly identically. So the sequence of compare operation will be absolutely the same. I don't care about it. I'm care just only about moving data. And also it was some ideas that, okay, inline types could be very large. maybe we should do some tricky optimization. Just first of all, sort indices of our array, primitive indices, and after that, restore it by moving. And here I'll show you results about the total data sorting with all auxiliary details. I can't fit all results into one slide, so I'll show it by pieces. For small arrays, when we fit into L1 cache, what I see here, on X axis, it's different sizes. For 8, 16, up to 64 byte size of my objects. And Y-axis is time in microseconds, then lower than beta. And here, for small arrays, for data which fit into L1 cache and I don't have cache misses, I see that for all cases, simple inline classes is faster than references, even if I move more data. It doesn't matter. Okay, let's do the array a little bit larger when it doesn't fit into L1 but perfectly fit into L3 on that laptop, on my laptop. Every data is gathered to my laptop just to show it. And again, inline class is faster everywhere and a little bit mess for very large, like 64 bytes inline classes. But anyway, trick with indexed inline helps us in that case. Okay, let's do it again larger and fit it into L3. And here's the only case where references became winning, but only for large classes and etc. Let's do it again larger, just 400 elements. And again, situation return to back. Our inline class is faster than references. And let's do yet another larger array. And again, I can see that inline class is faster. Indexes is better in that station, but inline classes is better than reference. And the general conclusion, which I may do from that just quite simple result, that the dense data location which we get for inline classes is much, much better for performance than moving less data. The cost of some losing of spatial locality is much higher than cost of moving more data, and it gives for us benefits. So inline class, as I think, give quite a lot of performance benefit for us, and we could use it in the future probably if you want. So here are links for our projects. We have a wiki page publicly available which contains a lot of details. If you wish, you may participate in discussion. We have two different mailing lists, one for internal specification committee group. Not internal, I mean that you can't write, they only read. And Valhalla Dev is general discussion mailing list. You may ask any questions there, show any examples, what you have. And if you wish, you could download it as repository and try it. But I promised soon it will be in main trunk, not turned on by default, but under an option as a feature preview, it will be available. So thank you very much. Thank you for coming. Any questions? Where is the microphone? There is a microphone there, please. Take it.
Hi, thanks for the talk. I wonder, how does Project Valhalla play with Graal VM, for example? Or do you have any insights on performance? Do we get anything automatically, or do you have to work on something special for it?
It's a general question to Graal team. It's a little bit different team, and right now there are no value types implementation in Graal. It's just a question to implement it. When guys implement it, we will check performance of it.
A quick one. So how do you compare? So this is very similar to C++. You guys are kind of closing the gap. How do you compare to C++? One. Two, what happens when you assign two value types Do you copy or do you do move semantics? Do you consider move semantics from C++, et cetera, et cetera, et cetera? I think C++ went through this many years ago.
It's a little bit different. In C++, even if you have struct or whatever without references allocated not in heap, the object still has identity. It has address inside.
Because you can take the address of
Yes.
operator, but
Yes.
you don't have that. You kind of
we
simulate
don't
it,
have
right?
it completely. There is some description how it put into array, but there is no any limitation for that. It is possible automagically. We don't play with that yet. It's not a goal. But if you have, for example, array of inline type, do you know about such switches from array of structures to structures of array, vice versa? Optimization. If you have array of structures, some optimizations, there are some optimization. When we move to a structure of array, when every field of our original structure is put into the own array. Sometimes it's very helpful for vectorization and optimization. And we can do it automatically, theoretically. We didn't play with that. We don't have that goals here. There is no any kind of limitation and specification how it put into array. The same for container. And if, for example, talking about local variables, inline types, implementation completely has no local allocation of inline type on stack. For local variables of inline types, it's just a set of primitive variables for fields. It's completely scalarized. And every field of our inline type may live in different places. And it provides us very nice optimizations.
And the last, what happens when you assign?
For assignment, you move the whole value of inline type.
You do the copy, mem
Yes,
copy,
sure,
basically.
sure.
Yeah. And the object also, when you assign two objects, inline object.
If we assign inline value into object, we have to do a heap allocation. We have to do boxing. We box it.
You have to box it?
Yeah, we have to
Okay.
box it if
Thank you.
hotspot can't eliminate boxing and prove that boxing is not required. Of course.
Thanks, Sergey.
I had a question about backing arrays of inline types with off-heap memory. Is that a heretical question?
It's not a theoretical question because of
Heretical, not theoretical.
no, it's already became a practical question. We got that question constantly. First of all, it's the first question for us, first implementation is to joining Valhalla with Vector API. Because of you know what Vector API is okay. Vector API should be inline classes, Vector API values, but Vector API requires specific layout of data, which depends on hardware. And in general, right now, user data inline class has no control of layout. Somehow, that problem will be solved for Vector API. Vector API will be inline classes, but with required hardware layout. And the general question how to exploit, how to control layout of inline types for other cases except of Vector API, mostly it's joint project with Panama when we are going to move it to native 12 heap. And right now there is no solution which we can show you, but it's it is in our list to deal with that, to provide perfect way. No more questions? Yeah.
Okay. Do you plan to support variable length inline type? So effectively converting string, for instance, into an inline type?
No. No. Variable length classes, or so-called fused classes, fused strings. First of all, it doesn't relate it to inline classes, because of you may still locate it on heap, and you may remain it as a typical Java object just to attach our array to that for string is so-called fused strings or any kind of fused objects like big integers, obvious candidate for that. It requires two implementations, other projects, which we called arrays.2.o. Have you heard about that? It's other projects. It's called arrays2.o. And from that projects we will get probably some fused string, etc. The other question about, is it possible to make a string an inline type? String has 3 fields. It's immutable. Don't care about array. Don't attach array about that. But could we make a string as an inline type? The answer is controversial. Yes, we can make string as an inline type, but it looks like we won't do it. Because of so many applications, they stuck with strings identity. They're doing synchronization on that. They used to base the functionality on string intern function and reference comparison. And if we'll change string to inline type, a large set of applications in the world will crash. Thank you.
I have one.
Oh,
I have one more question.
yes.
Here it is. Sorry.
Yeah.
Yeah. So we are running some big server by using Java, and I'm supposing if I turn on that Valhalla, right? Valhalla. Sorry.
Yeah.
If I enable it, so am I supposing to expect that the TLP memory usage increasing and the heap memory is decreasing? Is that correct?
It's.
I mean, the thread level memory usage.
I understand that question, but I don't think that it will be that way because of yes, the size of threads is increased. Even there are some examples when you may get stack overflow exception earlier in case of inline types, but it's mostly related to when you have inline types as arguments and results, but not for locals. For locals, it's pretty highly optimized for current examples. But definitely, I never saw that stack access provide a very large impact to TLB. From my experience, from my data, I saw mostly heap provide impact to TLB, not stack data. So in that case, I think it will be even better. And like the other case, which we can see on comparison of hash map inlining the first element in the bucket, I saw that TLB amount of TLB misses decreased significantly because of data locality. If you have reference, you're going to other page, you have TLB miss or whatever. But if data is local, even you require a little bit more pages, but it's the same subsequent pages of memory, not random references to other pages, and in that case it provides better behavior for TLB.
Thank you.
Okay, probably we are out of time. Sorry for that.